Hey guys, welcome back to another Math with Max, and the dogs are asleep again, so there's probably not going to be, they're literally snoring right now, so like I said, probably not going to happen seeing them today, maybe at the end, but all right. So today we're talking about input-output tables and additive and multiplicative patterns. So go ahead and get out your journal. I'm using my third period journal right now, and this sheet of paper. If you don't already have it, you can get it off my desk. You should also have a tan sheet of paper for small group pink or tan, I can't remember. A pink sheet and a tan sheet. Go ahead and staple those together. Put the writing on top, the input-output table writing, followed by the small group, followed by this one. So this one should be the last one stapled. So pause this video, make sure you have all three papers, and get them stapled together, please. All right, so go ahead and get out your journal, turn to your table of contents. We're gonna do some really quick, easy notes. You're gonna be like, you're gonna wonder why we're even taking it, but the reason is because for the vocabulary part of it, you might see these words on the test, so I wanna make sure that we understand what everything means, okay? So get out your journal, and I'm gonna make sure you can see it right here. Right here, number 42, additive and multiplicative patterns. Additive, ADDITIVE, multiplicative, MULTIPLICATIVE, patterns. So additive and multiplicative patterns. And then I'm going to turn to page 40, what is it? 42, I said, right? 42 in my journal. All right, so before I start giving you the notes, let's talk about additive and multiplicative. So first of all, you already understand what the word additive, or you've heard the word add, so you can get an idea of what additive means. And then of course, you've heard the word multiply, so you can understand what the word multiplicative means, okay? So this applies to input-output tables. So additive simply means when the rule uses addition, and then multiplicative is when your rule uses multiplication. So again, pretty self-explanatory, right? Additive, multiplicative, when are you adding, when are you multiplying? Now, it can get tricky when we're not paying attention to the full list of numbers that are there. I told you before, whatever you do for the first one has to work for the second, the third, and the fourth. So you can't just stop at your first one. You got to keep going down, because whatever you do for the first one has to work for all of them. That's the rule. The rules, you have to follow the rules like you would in class, right? So you're following the rules on this input-output table. So it's the same thing, okay? So on page 42, I'm going to start off by putting my title, Additive Multiplicative Patterns, and then I'm going to write additive rule uses addition. And then I'm just going to give it a little example of that one, and then we'll do the same thing for multiplicative. Okay, so pause the video and just make sure you have that written down. So the next thing I'm going to do is I'm going to write down, I'll make a little chart, T-chart, okay? And I'm going to do my X's and my Y, okay, just like that. Okay, and then the numbers that I'm going to use for this one are, sorry guys, I have all my stuff on the floor right here. The first pair is going to be 3, 9. The second pair is going to be 4, 10. The next pair is 5, 11. And the fourth pair is 6, 12. Okay, so my order of operations are falling out. Okay, so I put down these as my additive pattern. So as you can see, starting here, we have 3 turning into 9. And you might be saying to yourself, well, Miss, I know that 3 times 3 equals 9. And yes, you're right. 3 times 3 does equal 9. But then when I go to 4 and the 10, does 4 times 3 give me 10? No. If I know my 4s, I know that 4 times 3 is going to give me 12. So it's definitely not multiplicative here in this case. We are definitely going to be adding. So how do I get from 3 to 6? Obviously 3 to, I'm sorry, not 3 to 9, 3 to 6, 3 to 9. How do I get to 3 to 9? I'm going to add 6, okay? And then the same thing here. How do I get from 4 to 10? Add 6. How do I get from 5 to 11? Add 6. And then how do I get from 6 to 12? Add 6. So if you're getting stuck on these, you know you can always do the inverse operation. So for example, if I can't figure out what the rule is, here, instead of adding, or instead of trying to figure out what the missing number is, I would write, I could do 10 minus 4, so I know that 4 plus 6 equals 10. So then what is the rule? I'm going to write the rule over here. Y equals x plus 6. So that rule is going to work for all of them. And then underneath that, I'm going to write my rule in words, like just what we talked about before. Okay? Output equals, oh, there's Rocky. There he goes. Input plus 6. Okay, so just like that. Output equals input plus 6. Okay, so that's the first one. Underneath that, I'm going to write multiplicative. Okay, multiplicative. And you can do a little squiggly if you want. I bet you any second here, Rocky's going to ask me if he can go outside, and I'm going to tell him no. So I might have to yell at him right now. Okay. So multiplicative, we just talked about multiplicative. We just told you. So obviously multiplicative, just like when addition is a rule that uses addition, this rule is going to use multiplication, obviously. Okay, so just like that. And then the same thing, I'm going to create a little T-chart there, X and Y. Okay. And then fill it in. My first pair is going to be 3, 9. So again, I'm still going to use that 3, 9 again so I can show you how easy it is to get mixed up. So 3, 9. Then I'm going to go to 4, 12. So 4x, 12y. 5x. Oh, sorry, I made my 5 a little ugly. 5x and then y, 15. And then 6x and then 18y. Okay, so I should have that. So a person who's not paying attention will think again, could either think again plus 6, but then if I go here, well, 4 plus 6 is 10, not 12. So that tells me that I'm multiplying. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, and then 6 times 3 is 18. Okay, so now I'm going to write my rule. Y, and in this case, I'm going to do it where the number is right next to the X, right next to the variable, so we can get used to seeing it like that, okay? So Y equals 6. Are we multiplying times 6? Nope, I messed up. My bad. Okay? Y equals 3x because we're doing 3 times 3 equals 9, and 4 times 3 is 12. So Y equals 3x. So just ignore what I wrote right there. Okay, so y equals 3x. So again, just ignore what I put there. Pretend he's not there. Sorry. And then we're going to write this in words. Okay, output equals input. What you doing, Rocky? Output equals input times 3. Okay. Output equals input times 3. Okay, so that's basically additive and multiplicative patterns. Super simple. You just have to focus on making sure you go past the first one because they're always going to try and trick you with the first one, and you have to get down to the bottom ones. Okay, so that's that. We're done with this. Put it aside. Now you need this one. So if you've already stapled your 3 papers together, which you already should have, go ahead and grab this one. We're talking about this fast focus one right here. Okay, so I want to talk about this top one right here. Okay, sorry, I have to make sure I can see it. Okay, so this one right here, I'll read the question in just a second, but if I'm looking at the rule, it says y equals x plus 1/2, okay? So we know that we're dealing with fractions here. And we kind of get scared sometimes when we're dealing with fractions. Oh, you know what? Let's talk about on the coordinate grid. What does it mean to be a half? Especially when I'm looking at these guys. On these guys, there isn't a line in between each number. So let me show you what I mean by that. Okay. When they do the half sometimes, or the 3/4 or the 1/4, sometimes they don't skip a line in between the numbers. Sometimes you have to go in between. You have to find it in between, just like it was on the coordinate grid quiz that I gave you, I let you either pick to put a line in between, or you just shot up in between the two numbers. So for example, if this is my x-axis, okay, and I'll show you in just a second. I have 1, 2, 3, okay? So this 1, 2, 3, this line and this line could mean the half. So after 1 would be 1.5, or 1 5/10, because those can be the same thing. And then over here after the 2 would be 2.5, because it's halfway. I know I didn't do it perfect. Ignore that, okay? It would be halfway between 2 and 3, so 2.5, or 2 5/10, which anytime we have that 5/10, that automatically means half of something, okay? Because it's half of 10, 10ths place, so half of 10 would be 5. So that's why you always see the 5 here. Okay, so if this is my origin over here, going in 1, 1.5, 2, 2.5, 3. So that's one way to see it, okay? The other way to see it, like I was telling you guys before, again, if this is my x-axis, I have 1, 2, and then 3. So 1, 2, 3. So let's say they don't have any lines in between here. There's nothing there. So halfway between 1 and 2 would be here. So you would, in between your two lines going up, you would have to find your point. And that's what they've done on these ones. So when I'm looking over here for my answer, I have to make sure that I'm going in between the two lines. All right, so the question says, Mario is going to complete the input-output table below, then graph the ordered pairs that it generates. Generates just means what it makes. Which graph shows the ordered pairs that would appear in the completed table? So what I've done is I've taken that ordered pair, and again, I'm talking about on number 1 on this side, talking about Mario, and I just wrote it over here. So it's the same thing that you have on your paper, but mine's over here. All right, so I know my rule. I'm adding a half to whatever my x is, okay? And this one's pretty basic. There's no like changing the denominator, you know, flipping the fraction. There's nothing like that. I literally just have to add half to whatever it is that I have. So on this first one, I'm adding a half to the x, okay? So if my x is 1, where's my pencil? Where's my marker? Oh, here it is, in my marker box. Over here. Okay, so on this first one, I'm simply taking the 1, which is my x, and I'm adding the 1/2, okay? That's all that's telling me. X is my 1, so 1 plus a half would be 1 plus a half, 1.5. Okay, that's where I'm going to put this right here. So in my first y, I should have 1.5, just like that. Okay, and then I'm going to do the same thing for the second one. So my second one is 3.5, and I'm adding a half because whatever my x is, I have to add the half. That's how I get my y. So 3.5 plus half. Okay, now notice here, my denominators are the same. So there's nothing to change here. I'm going to get 3, and then I'm going to add the two fractions together. Okay, so my numerators, I add them together. I have, what side am I on here? I have 1 and 1, so that gives me 2. And then my denominator stays the same. Since my denominators are already the same, they get to stay the same also. Okay, but what do you notice? I have 3 and 2 over 2. So when my numerator and my denominator are the same, that adds another 1 to my 3. So what do I really have here? I don't have 3 and 2 2's. I have, 4 now, right? That's a 4. Okay, because this right here turns into another whole. So it's 3 and a whole. That actually equals the 4. Okay, I'm going to do the next one. The next one's 5.5. And again, I'm adding a half to it. So 5.5, and you can probably guess already what's going to happen here. 5.5 plus the half. Think about pies, you know, you're cutting in half and you're giving another half back. Like, obviously you're going to make a whole nother pie there. So we have 5 plus the half and the half. So I'm going to get 5 and 2 over 2. Same as before. So again, I have another whole here. So I don't really have 5 and 2 2's. I actually have 6, right? So here I have 6, okay? So that's what I should have so far. And then I'm going to do the same thing here. I'm going to add a half plus my 8. So 8 plus the 1/2. And that's just easy. I just put them together because it's not enough to make, the half is not enough to make another whole. So it's just 8 and then plus whatever else I have plus 8.5, right? So over here, I'm going to put 8.5. Okay? So this is what I should have now. So now that this is done, now I can go to my grids and I can figure out which one matches, okay? So I know that my first pair has to be in 1, up 1.5. So I go to my grids and I'm gonna go to the one that starts at 1. It has to be right on the 1, okay? My first point is right in on the 1. So if I go and I look, I can already see 2 that are out. If you look at A, oh, you can see that or not, on A, that they went in between the 1 and the 2. So what did I just tell you before? If it's in between the 1 and the 2, then that's a halfway point, isn't it? Yes, I did. I told you that. So that tells me that A is out because they've gone halfway between the 2 numbers. And then the same thing on, I think, yes, is this one? Yeah. Same thing on C. They did the same thing. They went halfway in between. So they're already starting in the wrong place. So that leaves me with, what is this, B and D. Okay, so I know that my first pair has to be in 1, up 1.5. So I need to check in C. Sorry, it's hard to see it backwards like that. I have to look at it first. Okay, so it seems that on B, they did go in 1, 1.5. Okay, if you can see that or not. They did go in 1 and then up 1.5. So that one's okay. So let me check over here. Did they go in 1? Yes. But did they go up 1.5? No. They went up to 2.5, I believe. Yeah. So D is probably not gonna work. So we need to finish checking out B over here and make sure that all the points there are correct. Okay. So my next ordered pair after 1, 1.5 is 3.5, 4. Okay. So I'm gonna look over here on B. Did they go in 3.5? Yes. Did they go up 4? Yes, they did. Okay. Then I'm going to check the third one. Did they go up 5.5? Up 6? Yes. And then in 8, up 8.5. And yes, they did. So that tells me that on this one, B is the correct answer. Okay. And then you're going to do the same thing down here. I just want to talk to you really quick about that particular rule that they gave you. And I used, most of you probably already know, I just want to clarify for anybody that might be a little bit confused. So on this one, the rule is y equals 0 and 5/10 x. Let me make sure this is not blurry. Okay. Y equals 0 and 5/10 x, or multiplied times x. So y equals 0 and 5/10 x, like that. Okay, so we already talked about this. What does it mean when the number is right next to the variable? It means to multiply. So what do you really have here? Y equals 0 and 5/10 times, and I'm going to use the dot because I have an x already, so I don't want to do another x, do I? Like that. Okay, so same thing. Same thing, I've just made it more clear to myself, okay? And you're going to do the same thing. So you'll start plugging them in here. So the x is going to change to a 1 for the first one. Y equals 0 and 5/10 times 1. Okay, so obviously anything times 1 is itself, right? So that tells me that my y in this case equals 0 and 5/10. So 0 and 5/10 equals 0 and 5/10 times 1. Isn't that true? Yeah, because anything times 1 is going to be itself. So on this first one right here, I'm going to have, what is this one? 1 and then 0 and then 0 and 5/10. And then you'll do the same thing for the rest of, just like we did with the fractions, but now with decimals, okay? Just make sure that you move your decimal the correct amount of spaces. They should be stacked on top, especially because you're going to go into 2s, 3s, and 4s. Make sure that you multiply them correctly. Don't guess. I still want to see the work for those, okay? So that's those on the front. Now we're going to go to the back. On the back, you have a lot of input-output tables, right? They're asking you which ones are additive and which ones are multiplicative. So you do have to go through each one of them. I suggest starting with each of the top ones. and checking to see if you can rule out any of them. So on this first one, it's asking which one is showing an additive pattern, okay? So the first number you have on A is 9, and then your X is 18, okay? So obviously you can add 9 plus 9 to give you 18, okay? So far that one could still be additive, you don't know. So you could go to the next one, 9 to 36. I mean, obviously all of these could. I would actually move on to the second one. Find out what the rule is for the first one and then try it out with the second one. If you want, you can go individually. It's up to you how you do it. You just have to make sure that you're choosing the one that's additive or choosing the one that is multiplicative, okay? And then on the bottom one, they gave you the graphs here. So you're actually going to have to, on a sheet of paper, make the t-chart like we did on these, make an actual X and Y, and then figure out what the rule is and figure out which one is showing additive and which other three are showing multiplicative, because that's really going to be your only way. You need to clearly set out your work. Just like I talked to, I think one of my classes earlier today was that I'm noticing that a lot of you are not writing down the information that is given to you in a word problem. For example, that word problem that had to do with the 4/8 or the 5/8 of the 40 minutes. Draw a picture. Think about what's happening. You need to write down, because for me, when a word problem is large, I still need to write down everything so that my thought process is clear and I see every step, okay? And we need to get used to doing that. We are extremely close to STAR, so I need you guys to get into the habit of writing down those steps. Some of you are still working on it. I know some of you got it down and you're using it, but we need to be more diligent about doing it, okay? So I think that's it. Get to the rest of your centers. You'll have tomorrow as well, and then everything will be due on Monday as usual, okay? What else? I'm trying to make sure I don't forget anything today. Hey Maxie, you want to come say hi? You want to? Oh, come here. Hey, come here. Come here. He doesn't want to say hi. Sorry, guys. It's just Rocky today. He just did his little walk by. Anyway, okay. Make sure you get your work done, and I will see you guys later. Bye.